Hello students, this video lesson will be about rounding decimal numbers and scientific notation. Rounding our decimal numbers, we'll have to be familiar with our place values. So basically, when we're rounding decimal numbers, we need to locate the place value you want to round to. Then look at the number to its right. If the number to the right is less than 5, 4, 3, 2, 1, or 0, then drop it off, and all the other numbers to the right of it as well. If the numbers to the right is greater than or equal to 5, 5, 6, 7, 8, or 9, then the place value number in front, the number to the left, increases by 1, and all the numbers to the right are dropped off. So, for example, round each of the numbers to the nearest tenths. The first thing we have to do is we have to determine where the tenths place value is. Tenths, tenths, tenths. So we're going to immediately look to the right of the tenths place value. My first one is a 5. So that's going to round that 2 up to a 3. And we get 133 and 3/10. On my second number, the number to the right of the tenths place value is a 1. So that means the 1 and the 9 both drop off, -6 and 2/10. On my last number, the number to the right of the place value I want to round to is 9, which means I have to add 1 to the number in front, which makes it a 10, which makes me add the one in front of that up by 1. And then that's going to be making the one in front of that go up by 1. So when I round this to the nearest tenth, I'm going to get 90. But since it said round to the nearest tenths, I'm going to go ahead and write 90.0. My next set of 3 numbers, it says round each of the numbers to the nearest thousandths. Again, the first thing I want to do is find the thousandths place value. So I always like to count tens, hundreds, thousandths, 10 hundredths, thousandths, 10 hundredths, thousandths. Once I've located my place value that I want to round to, I simply look at the number to the right, and if it's 5 or higher, I round up. If it's not, I simply drop it off. For my first one, I'm going to have -1 and 499 thousandths. On my second one, since the number to the right of the thousandths place value is a 9, it's going to move it up. So 9 and 991 thousandths. And my last number, the number to the right is 7, which is going to make the number in front go up by 1. So I have 15 and 388 thousandths. Okay, go ahead and stop the video and give it a try. See how you do. So how did it work out? 14 and 33/10. Oh, 14 and 33 thousandths. We're rounding these to the thousands or hundreds. -3 and 57 hundredths. -7 and 99 hundredths. Looking ahead, and I got all tongue twisted there. Okay, moving on. Scientific notation. Very large or very small numbers are tedious to write out. Scientific notation provides a much more manageable way to write these types of numbers. An example would be the distance the Earth is from the Sun, which is approximately 93 million miles, or the size of a water molecule, which is approximately 282 10 billionths of a centimeter. Those two numbers would be ideal to have written in scientific notation. Within scientific notation, one digit and only one digit, 1 through 9, must be in front of the decimal. After the decimal number is a time sign, an X, and then 10 to some power. For really big numbers, the power will be positive. For really small numbers, the power will be negative. So in our decimal place value chart, place values are powers of 10. As I move to the right, I get smaller, and I have negative exponents on my tens. As I move to the left, I get larger, and my powers are positive. Change a large number to scientific notation, just count how many place values the decimal will need to move so that only one digit, 1 through 9, is in front of the decimal. So I'm moving to begin with, your decimal is always on the far right of a number if it's not there already for you. So I'm moving to the left 7 place values so that only one digit is in front. So my number becomes 9.3 times 10 to the 7th power. My second example, I'm moving my place value 9 place values to the left so that there's only one digit in front, which becomes 4.383 times 10 to the 9th. I've taken a really large number and I've written it into scientific notation. Now to change a small number to scientific notation, just count how many place values the decimal will need to move so that only one digit, 1 through 9, is in front of the decimal. However many place values you moved, that number with a negative sign will be the power 10 is being raised. So again, my decimal is already here for me, but I have to determine how many place values I'm moving. So on my first example, I'm moving 8 place values. So until I get to a number of only one digit to be in front of the decimal. So I end up with 2.82 times 10 to the negative 8 power. On my second example, I have to move 4 place values in order to just have one digit in front of the decimal. And that creates 1.35 times 10 to the negative 4th power. Okay, it's your turn. Go ahead and stop the video and give it a try. Change the below numbers to scientific notation and then check your answers. How'd you do? 4.56 times 10 to the 11th, 8.98 times 10 to the negative 5. Changing a number from scientific notation to a number that contains no exponents. So we're just going the opposite direction. If the power on the 10 is positive, move the decimal that number of place values to the right. Zeros may need to be added if there are not any place numbers in those place values. And if the power on the 10 is negative, move the decimal that many place values to the left and put any extra zeros in front, or actually you need to put one extra zero in front of the decimal and then add any zeros that may need to be added for those place values that you moved the decimal. My first example is 5.89 times 10 to the 4. I'm taking my decimal and I'm moving it 4 place values to the right, and I'm going to have to add 2 zeros to fill in those 2 place values that I had to move. Now my second example, I'm going to move my decimal 3 place values to the left, and again I'm going to have to add in some zeros there for those place values that are emptied. But I always want to put a 0 in front. So let's go ahead and stop the video and give these two a try. So how'd you do? One easy, quick way to look at this If it's a positive exponent, it's going to be a large number. If it's a negative exponent, it's going to be a decimal number. So on my first one, I had to move 7 place values to the left. On my second one, I had to move 5 place values. Actually, we're going backwards, right? So 5 place values to the left. On the first one, we had to go 7 place values to the right. Okay, discussion board problems. Write the below problems on paper, complete them, scan or take a photo image, and upload to the appropriate discussion board form. Be sure to show all your steps. Your little, you might just be able to show your place values that you're moving to, or mark the place value that you want.